Hey everyone, we're going to find the inverse of f and then check by composing f with f inverse. We're going to graph both f and f inverse and state the domain of both. Okay, so first we change this f of x to y and switch the x and the y, and then solve for y. All right, now we're going to check. So this is your f inverse. Now we have to check. By the way, both of these, the domain is all real numbers and the range is all real numbers because it's a cube root. The next one we do, the quadratics, we're going to have some restrictions we have to do. So basically, let's check. I'm going to compose f with f inverse first. When you do that, I'm going to go ahead and write the outer function first and leave my x blank there. And then I'm going to plug in my f inverse, my inner function. And then the cube of a cube root cancels out. So you have x plus 1 minus 1, that equals x. So that checks. Then we have to also go the other way and check f inverse with f of x. So I'm going to write f of x down, f inverse down, and I'm going to leave my x blank and plug in x cubed minus 1 plus 1. So what happens here is the 1's cancel, and then these will cancel out, and we'll just be left with x. Okay? And so did we do everything? Yeah. Now we have to graph it. So I'm going to graph my line y equals x. And the best way to do this is we're going to graph f first, which is going to be x cubed minus 1. That's your f. So that's the cube root function that has a y-intercept at -1. And also x-intercept here. And you kind of should know what this looks like through our parent functions. Let's let this be in purple. So it's kind of like this. All right. Well, that's not very good. But anyway, now the inverse, f inverse, is the cube root of x plus 1. This means it's a horizontal shift to the left by 1. So we're coming over here. And it's also going to go through here. Let's do this in, let's see, green. Okay. And then you should know what a cube root looks like. So it's going to be like this. So there it is. Okay. The next one's very similar. So if you already got how to do this, you're good to go. Let's just do the next one is f of x equals x cubed plus 1. So switch, write it with y, switch the x and the y, solve for y. We're just going to cube root both sides. And now we have to check f. Again, the domain and the range are going to be all real numbers. Well, let's go the other way. I wrote it down this way. So let's check it this way first. So we write the inverse down first. But where we have the x, we're going to plug in x cubed plus 1. This leaves us cube root of x cubed, which equals x. And let's go the other way. F composed with f inverse. This was f inverse here. All right, so I'm going to write down f first, leave it blank for the x and plug in cube root of x minus 1. This all cancels out. So we have x minus 1 plus 1, which equals x. Now all we have to do is graph it. So my first of all, we have to graph y equals x. Again, it's all real numbers for this. Now the first one was f, and f equals x cubed plus 1. So we're just going up 1 here. It means it's going to go through here. And so it's kind of like this. Whoa. Okay. Let's go back. There, something like that. And then f inverse was the cube root of x minus 1. That's a horizontal shift to the right by 1. So we're going to go right by 1. It's also going to go through here. And then it's kind of lays more flat here. You know this through your parent functions. And that's, I guess, the best I could do. Okay, the next ones we're going to do are the inverses of quadratics. Thank you and have a nice day. Bye-bye.